Assalamualaikum warahmatullahi wabarakatuh. Hi guys, my name is Rizaena Anggia Putri, number 27.
My name is Cahya Setyautami, number 4.
We are from Mathematics Education 5A, Fakultas Keguruan dan Ilmu Pendidikan, Universitas Muhammadiyah Purwokerto.
Today we will explain about a phenomenon about an integral in real life. In mathematics, an integral assigns numbers to functions in a way that can describe displacement, area, volume, and other concepts that arise by combining differential data. Integration is one of the two main operations of calculus, with its inverse operation, differentiation, being the other. Symbol of integral is like this. Given a function f of a real variable x and an interval a, b of the real line, the definite integral is like this. Is defined informally as the sine area of the region in the xy plane that is bounded by the graph of f, the x-axis, and the vertical lines x equal to a and x equal to b. The area above the x-axis adds to the total, and the below the x-axis subtract from the total. The operation of integration up to an additive constant in the inverse of the operation of differentiation. For this reason, the term integral may also refer to the related notion of the antiderivative. A function f whose derivative is the given function f. In this case, it is called an indefinite integral, and it is written like this. The integrals discussed in this article are those term-defined integrals. It is the fundamental theorem of calculus that connects differentiation with the definite integral. If f is a continuous real-valued function defined on a closed interval a, b, then once an antiderivative f of f is known, the definite integral of f over that interval is given by this. The principles of the integration were formulated independently by Isaac Newton and Gottfried Wilhelm Leibniz in the late 17th century, who thought of the integral as an infinite sum of rectangles of infinitesimal width. Gerhard Riemann gave a rigorous mathematical definition of integrals. It based on limiting procedure that approximates the area of curved linear region by breaking the region into thin vertical slabs. Beginning in the 19th century, more sophisticated notion of integral began to appear, where the type of the function as well as the domain over which the integration is performed has been generalized. Inline integral is defined for function of two or more variables, and the interval of integration a, b is replaced by curve connecting two endpoints. In surface integral, the curve is replaced by piece of the surface in three-dimensional space.
Application of integration is keep adding along increasing radius, keep adding along x-axis, keep adding along y-axis, keep adding along increasing height, keep adding along vertical curve plane or vertical rotation, keep adding along horizontal curve path or horizontal rotation. Only a fraction of light emitted by sun comes toward the earth. The total energy generated by this cubical sun is integration of 4p squared. That fraction of energy is the earth. Integration of this one above another produces a cylinder is integration of 4 pi r square dh. Keep adding this of surface area. Keep adding this of surface area 4 pi r square along the height 4 pi r square h. Application of differential calculus. Adding hollow rings of increasing radius produces a circular surface or disc. Mathematically, integration of 2 pi r dr equal to pi r square. Pi r square is area of cycle and 2 pi r dr is circumference of cycle. Adding such this one above the other to a height dh means direction of height. Surface area of cycle equal to pi r square or skin area. And from this, now keep adding such this along increasing height or dh. Become this and then surface area, skin area of a cylinder. Now you can make a cylinder.
The integration of 1 dx is equal to x. Dx means moving along direction of x-axis. Integration of dx is actually integration 1 dx. We just loosely write it as just integration dx. 1 is magnitude and dx means direction.
Now let's put a limit on the integral from 0 to 9. How long will be brick line be? Dx is mean moving along direction of x-axis. This line will be of like 9. In layman's word, if you keep adding brick of like 1 in the x-axis direction dx from plane 0 to 9, you will be left with a brick line of like 9. If the limit of the integration was from 0 to 5, is integration of 1 from 0 until 5 dx equal to 5. In general, if the limit of the integration was from 0 to x, is integration of 1 from 0 to x dx equal to x. You will be left with a brick line of like x. One-dimensional integration of dx equal to x is integration of dx is actually integration of 1 dx. It means you are adding brick along the x-axis and assuming that the length of energy brick 1 unit. If you adding, what you will get a line. How long will this line be? It depends on what x coordinate you stop plus. Two-dimensional integration is integration of dx dy equal to xy. Double integration is integration along any two different dimension or direction. Triple integration is adding brick along all the three dimensions x, y, and z axis. The lower limit of integration is from where you start adding starting point, and the upper limit is where you stop adding starting. Ini stopping itu atau starting, okay? And the upper limit is where you stop adding stopping point. Magnitude of brick to be added dx, dy, and dz. Only a fraction of light emitted by the sun reaches the earth, and to find the total light emitted by the sun across its surface. Surface area of sun is integration from 0 until 4πr squared. That function of like d theta that resets the Earth. To form shapes, integration of many points one after the other give rise a line. The other give rise to a line is integration of many such lines one above the other give rise of a rectangle. Integration of many subrectangle surface one above another gives rise to a box-like structure.
That's all from our explanation about the phenomenon of integral in real life. Thank you for watching and see you on our next video. Assalamualaikum warahmatullahi wabarakatuh.